Hello, this is Scott. So welcome again to my data science advanced analytics series. Today I'm talking about R and R Studio, specifically time series analysis forecasting models. Picking up from last time where we talked about innovations in state space models. This time talking about estimating models and maximum likelihood with ETS, the ETS function from the FPP2 package. And then next time we'll actually talk about forecasting those models created in R Studio. Okay, so jumping right into it, I needed to cover a couple topics before we get into R. So previously, when we talked about model selection, we were basically minimizing the sum squared errors. Today, we're going to switch and talk about the maximum likelihood, the MLE approach to model selection. It turns out where additive models actually produce the same results, but multiplicative models, the MLE method using ETS will actually produce different results. So in ETS, what we're essentially trying to do is we're trying to estimate the smoothing parameters, the four smoothing parameters, alpha, beta, lambda, and phi, and we also estimate L naught, B naught, S naught, S minus 1, S minus 2, depending on what we select. And then, so that's kind of what we're doing with the ETS function itself. And in practicality, the smoothing parameters range between 0 and 1, non-inclusively. It turns out that in practice, R is going to set the bounds for phi between 0.8 and 0.98. And then Heinemann, since we're using the FPP2 package by Heinemann, the ETS of A and N is actually between 0 and 2 for alpha, and you can see that the AAN model is 0 to 2 and 0 to 4 minus 2 times alpha are the limits there. And I'll just say, if you want designation, last time we had a previous section on what all of these different error, trend, and seasonality models are. So please go back one or two to find that. All right, a couple other comments about these models before we jump into R and R Studio. Number one is we are going to minimize the Akaike information criterion or the corrected Akaike information criterion or the Schwarz-Bayes information criterion. Those are going to be what we're going to be working on, and you can select those within the package itself. And then a couple of other comments. We need to try to avoid certain modeling types. So if you will, avoid these four different types of models within when you're performing forecasting, actually, or model development. So these three, and then multiplicative models. This comment is basically avoid it when the data is non-positive. Okay, and then we're going to actually, before we go into the demo, I'm going to make a few brief statements about the package itself. So what we have here is an example of the package where Y is the time series to be forecast. The model is basically a three-letter code indicating the model to be estimated. Here, ZZZ. And the ETS classification and notation. So some possible inputs are N for none, A for additive, M for multiplicative, or Z for automatic selection. And by the way, so I mean, you can, when you download the package, you can get all of this information in a lot more detail. But the damped piece of it is, if damped is true, then a damped trend will be used. If damped is false, then the non-damped trend will be used. And if it's null, then either the damped or non-damped trend will be selected depending on which model has the smallest value for the information criterion. And then here's the 4 smoothing parameters: alpha, beta, gamma, phi. And so if they're set to null, they're going to be estimated. You know, lambda here can also be transformed. The biased adjustment is true if lambda is not null. So the lambda function itself is going to be ignored if null, which is the default value. Otherwise, the time series is going to be transformed before to a Box-Cox transformation before the model is estimated. Let's see. On the additive only, only add models that with the added components will be considered if it's true. The restrict, if it's true, which is the default value, the models cause numeric difficulties are not considered in model selection, the ones that I just went through in the previous slide. And and then the multiplicative trend here is, so they're available but not really covered. If you want to go into a deeper dive, there's a much richer technical discussion of this. So let's jump over to RStudio real quick. Again, we're using this package, this FPPP package, FPP2, actually the updated package from Hyman. And if you were with us previously, we used this data set, which is of the Australian tourist data. And we're basically going to fit the model with all of the defaults and get a summary. So if I do that, well, all right, so if I do that, I can essentially see the output from RStudio or R. So the smoothing parameter estimates: alpha 0.19, beta 0.04, gamma 0.0002, and then the initial state. So L naught is, you can see here, is 32.4. Beta naught, and then here are the S naught estimates: S minus 1, minus 2, minus 3. So all of the different estimates, and then here's the information criterion, and it's going to use the adjusted Akaike information criterion by default, and then you can see the actual estimates based on the residuals here, the classical estimates that we talked about before. So what else would I want to do? Let me just get well, let's get a plot. So auto plot our fit, and we can get a plot like that. We can look at this series. Note that one of the things that we're not going to do in the ETS package itself is produce a forecast. We'll actually talk about that next time. And unlike cold winters and some of the other things that we've done in the past, it's not readily available in the ETS itself. So we'll show you how to do that next time. But I can get a plot, and I can look at the different components of the slope, which we saw was very small based on lambda, And anyway, I need to move on. I don't want this to be too long. Let me show you one other thing. So remember, we were talking about the fact that using a maximum likelihood model, the residuals are not necessarily the same, since we have a multiplicative model here, which is selected, right? The model selected an ETS MAM model. So if I want to compare the actual residuals and execute those, I can look at the residuals themselves versus the actual fit for this model, the difference between what it would be if it were an additive model itself. So anyway, I will end there, and next time we'll pick up with this information and we'll show you how to do a forecast. Thanks.